Hello and welcome back to another IB Math Speedrun with me, Vince. So in this one we're going to be continuing our exploration of the differentiation of trigonometric functions, so let's jump right in. So as you saw in the previous video, if you watched it, it's just extremely tedious to use the first principles to differentiate every trigonometric function. Luckily, we can use it once to find all the derivatives, which I will now list out. So, to make our lives easier, we know that if the function is y equals sine x, the derivative is equal to cosine x. For y is equal to cosine x, the derivative is equal to negative sine x. So we have the cyclical property, something like the where we were like multiplying I by itself, where it transitions from sine x to cosine x to negative sine x to negative cosine x, and then back to sine x. So if you differentiate a sine equation 4 times, you'll end up with the sine equation again. Now, using the quotient rule, we can find the derivative of the tangent function, and that's y is equal to tan x. Well, the dy over dx, if you want, you can try and quotient rule it, but I'll give it to you right now. It's secant squared x. Next, for the inverses, so y is equal to cosecant x, the derivative is equal to negative cosecant x cotangent x. So we ideally like to memorize these. Next, for y is equal to secant x, dy over dx is equal to secant x tangent x. I mean, we can also technically quotient rules all of these. And for y is equal to cotangent x, the derivative is equal to negative cosecant squared x. So yeah, using those, this next exercise is telling us to differentiate some functions. So the first function we have is y is equal to cotangent x. And well, we know this one already. It's simply negative cosecant squared x. So, I mean, that one is pretty easy. Dy over dx is equal to negative cosecant squared x. Okay, the next question is y is equal to sine 2x. And we did this one in the previous video, but it's too hard to use chain rule when we can simply use... Sorry, it's too hard to use first principles when we could simply use chain rule instead. So how do we do that? Let's say that u is equal to 2x, and then we have y is equal to sine u. Well, we can use chain rule because we know dy over dx is equal to dy over du times du over dx, so we differentiate both. Dy over du is cosine u, which we know is cosine 2x, and du over dx is equal to 2. So it's cosine 2x times 2, which is equal to 2 cosine 2x. The exact same result we got as in the previous video. Next equation, we have y is equal to cosine 8 minus 3x. And the same thing, we can use chain rule. Let's label this to cosine u. And then u is equal to 8 minus 3x. So we have dy over dx is equal to dy over du times du over dx. So dy over du is negative sine u times du over dx, which is negative 3. So we actually have 3 sine 8 minus 3x. So this is the new equation. Except the book has made an error for some reason. For some reason they haven't differentiated it properly. Anyways, moving on, our next one is we need to find the derivative of the following functions. First is cosine x raised to the 5th power minus 3. So, how do we find this? Well, let's label u is equal to x to the 5 minus 3, and then y is equal to cosine u. So like before, we have dy over dx is equal to dy over du times du over dx. So what is the derivative of cosine u with respect to y? It's simply negative sine u. What is the derivative of x with respect to u? That's 5x to the 4. So we get negative 5x to the 4 times sine u, which is x cubed, x to the 5th minus 3. So that is the derivative. Yeah. Next question. We have y is equal to secant times 4x cubed minus 2x squared plus 7x plus 17. So the derivative again, label u as this inside, we get, first let's get the derivative of the secant function. And the derivative of the secant function, if you remember, is secant x tan x. So we have secant 4x cubed minus 2x squared plus 7x plus 17 times the tangent of this. Tangent of 4x cubed minus 2x squared plus 7x plus 17. And finally, we get the derivative of this stuff inside the brackets to end up with the correct final equation. Sorry, that's not 4x cubed. Derivative of this inside is 12x squared minus 4x plus 7 times all of that. So that is the correct answer. Finally, on to the last one. And the last question is, we need to derive sine times cosine, sine of cosine of tangent of x. Okay, so this is a multi-chain rule function. So first, let's get the derivative of tangent of x. The derivative of the tangent of x is equal to secant squared x. So that was the easy part. Now we need to get the derivative of the cosine of the secant of, actually wait, let's write this out properly. So we have y is equal to sine u. U is equal to cosine of v, and v is equal to tangent x. So dy over dx is equal to dy over du times du over dv times dv over dx. So let's fill out the blanks. Dy over du, the derivative of sine u is cosine u, times the derivative of cosine v, which is minus sine v, times the derivative of tan x, which is secant squared x. So now we can substitute what u, v, and x are. So cosine u is equal to cosine v, which is just cosine tan x. So we have the cosine of the tangent of x times the sine of v, which is sine tan x, so times sine tan x times secant squared x. So yeah, quite a long equation, and that should be correct. So that is all for the speedrun. I hope you enjoyed it, and I hope to see you in the next one.